if we're given this velocity graph, we're going to find the total distance traveled. Again, these are the velocities, the speeds, after 1, 2, 3, 4, and 5 seconds. So after 5 seconds, the person stopped. If I want to find total distance, remember velocity to total distance, you have to understand velocity, do you understand, is the derivative of time, of position? Velocity is the derivative of position. So if I want to go from velocity to position, don't you have to integrate it? So what you need to understand here is you're actually going to be taking the integral of velocity in respect to time, so it's dt, and what's my interval? Well, what is it? From 0 to 5 seconds. That's what I'm trying to calculate. The total distance traveled, the total position after time, is going from here to here is integrating over that 5 seconds. Now, if we do this, well, we want to find the area in the curve. We don't have a formula, but can we look at these shapes and kind of find areas of trapezoids? And just approximate. The best thing you can do is approximate this one. So for the first rectangle, do you see you have a rectangle here? Oops. Can you kind of see if I just kind of make some rectangles? So make the rectangles and then make the little triangles above it, or I could use trapezoids too. Trapezoid would actually work better. But for it, actually let's just use trapezoids. I want trapezoids to be very accurate. Okay, so the width is 1 for all of them, correct? For the first trapezoid, what's my first height? About 85. Plus my second height is 55. Oh, by the way, don't we divide by 2? Do you guys remember that? Trapezoids, you take the, you're going to divide by 2. The width of each one's 1, and you divide it by 2. Anywho, that's the first trapezoid. Plus, what's the second trapezoid? The second one, that goes from 55 to 30. And then the next one goes from 30 to 20. And then the next one goes from 20 to 10. And then you go from 10 to 0. Now, if you find all those trapezoids, you're going to get approximately 145. Now, it's not going to be exactly that, but the book says 145. Got it? If we did all this, hopefully we get around 140. We probably won't get exactly that, but if we had more exact points, this is what you should get. So we're going to add up the inside. That's the velocity. Now, why, again, is the total distance the integral of velocity? Let's think about this. What you need to realize is if I integrated this, do you understand I technically, I'm going to jump down here, would have S sub t from 5 to 0? You guys okay with that? Isn't the integral of velocity position? Is that okay? So if I wanted to solve this, well, isn't that going to be S of 5 minus S of 0? Are we okay with that? Isn't that the position after 5 seconds, which is 0, minus the position at 0? If you subtract those, you should get that answer. Anyways.